Section 1.3 Part 1. I wanted to go over a couple of the examples within the textbook itself before we start working some of the problems in the homework. So this is one example. It says the figure shows a graph of a function g. It says find g of -2 and g of 5. And what that is really saying is function notation. It's saying when x is -2, what is the output? So when we're looking at this, we say g of -2 is equal to, we go over here to -2 on the x-axis, and we see what is its y value, right? We're look up and down the line here, the vertical line, to see where the graph is, and it just happens to be right there. So it's at 0. Now, g of 5 is equal to, we go to 5, and then what is its output? 1. So these are when they're giving you x values, right? And they're asking for the output. So you can kind of think of it kind of like this. It's giving you this part of the ordered pair, and it's asking you to find what is the y value, right? I'll take this back a little bit. There. What is the y values? That's really what the function notation is asking. So that takes care of A. For what values of t is g of t equal to -2? Well, this is an output, right? So what I want to do is I want to take and I want to look. Here's -1, here's -2. So I've got a point there, and there. So I want to think of it in terms of when they give me an output, I want to look at in terms of a horizontal line, right? Horizontal line at -2, because if you think about it, g of t is really y, right? So y equals -2 is the equation of a horizontal line. So these g of t equals -2 and y equals -2 are the same thing, seeing as function notation. The function notation is equal to the y. Now, so I've drawn a horizontal line, so I'm looking at, let's see, 1, 2, 3. I should do it from negatives to positives, so that'd be -5, -3, and 3. Okay, so there. Now, what is the largest or maximum value of the function? And then, so they're saying, what is the largest y value? That's what they're saying when they say, what is the largest or maximum value of the g sub t? Again, let me point out, this g sub t is really a y, right? So what is the largest or maximum value of y? So if that helps you. And you can clearly see that the highest point up here on the y value is at 4. So that answers 4. Then it says, for what value of t does the function take on its maximum value? Well, basically, let me erase that and redo that. Basically, they want the x value, right? So that would be what value of t? T equals 1, right? Okay. Now, so if you can get the ordered pair, the maximum would be the y value, and the x value that creates that maximum would be what you're wanting on the second part of that. So let me erase this. Okay. Now, intervals of increasing, and we're going to talk about intervals of decreasing too, okay? Because that's something that you need to kind of see. I normally do it from a transition point, okay? And they're going to do brackets. Traditionally, if you look at any math book or anything like that, they're using parentheses, instead of brackets unless it's an endpoint, right? So I just want you to kind of be aware of that this is not necessarily true, okay? But we have to do it based off of how they have it coded, which means that there's probably people that coded this that don't understand math. They're just writing it in, as opposed to math people that are writing this program. So, all right, so I digress. On what intervals is G increasing? So I want you to kind of look at this. Every transition point, and what I mean by transition point is where it turns and goes in the opposite direction. So we're going to draw up, we're going to draw it down, we're going to draw it up. Okay. So what I want to do is I want to create a horizontal line, and that's at, let's see, -4, 1, 2, and 3. I want to extend that on out as well. And then, of course, because this doesn't go on and it stops at 5 and -5 respectively, then I need to make sure I put my endpoints there. I do want to cover one thing real quick. If this did, it would be infinity. Now, the question is, how do I type it into this program? INF for positive, and then if you wanted negative infinity, it'd be -INF, like this. Okay, so those are two things some people have asked. How do you do infinity? That's it, INF. Okay, so just kind of make sure. All right, so what I'm going to do is kind of create boundaries, and this right here helps you to focus on the values that you're needing, because the interval of increasing or the interval of decreasing is where the transition is happening with respect to the x-axis. Okay, so you're telling the story along the x-axis. Now, from -5 down to or -5 to -4, it's going down. From -4, highlight this. From -4 down up there, it's going up, right? So it's going up, and then I want to grab another highlight that's different. And from here, it's going down. So that would be there. And then let's grab another one. There. And you can kind of see that it's going up here. Now, this only said, where's it increasing, right? So they're going to have you write it like this: -4 to 1 with brackets, comma, and then 3 to 5. Okay. Now, if they wanted, where's it decreasing, then of course, you know, I'd have -5 to -4, and then 1 to 3, and put a comma in between it. The rest of the mathematical world, if you have this, the rest of the mathematical world puts a U, because that's a union. Okay. I don't know why they're putting a comma there. Mathematically, that's not correct. But folks, we've got to type it in like that so that we can get the credit. Just know that if you have it, it's really supposed to be a U. And if you were to go to Academic Center and stuff like that, and you're getting help from, let's say, Mr. Reynolds or someone else, they're probably going to do the U. But just knowing this program, you got to put it in as a comma. Okay? So that's the interval of increasing. Again, I said if it was decreasing, then it would be this, right? -5 to 4, comma, and then 1 to 3. And once you get this right here on your, laid out and got all the transition points and labeled them, hey, I'm going down from here to here on the x value, I'm going up from here to here on the x value, then you've done the hard work. It's over. Okay, so just kind of keep that in mind. All right, let's go look at another one. And the other thing we got to look at is the vertical line test. Okay, Vertical line test is a way to be able to tell whether a function, to tell whether a graph is a function or not. All right. We look back, we talked about functions in 1.2. The x's can't repeat, and if they do, then they're stacking. So you can kind of see, like right here, your x value here, it stacks. So therefore, if I were to take a vertical line and move it, you can see that it fails, right? It touches it more than once. Now, if we look over here, then they've kind of drawn some vertical lines. Any point along this path, it's only touching it one time and one time only. Okay, so normally this is what I kind of say. I kind of say, if it looks like that, that, or that, it's not a function, right? C, backward C in a circle or ellipse shape, it's not going to be a function because it does a UE from left to right. Okay, so we want to kind of come down and show you some stuff. So vertical line test, graph represents a function if and only if the vertical line intersects the graph and at most one point, right? It only can touch it once. So I want to go and look at some examples. So your best thing is take your pencil or you take your finger, it's fine. Doesn't really matter. And just kind of, which one? Well, that passes. That one fails. Do you see that C there? You should be able to see that. Now, this one comes up and this keeps going. I want you to pay close attention. This is a function, okay? But I want you to pay close attention right here. Do you see how that one's open and this one's closed? So the open dot means it doesn't exist there. So if you were to merge those together, that closed dot would just make that line continuous. Okay, it would only fail if this one was a closed. Okay, then you'd have stack points. See if I got any more. Yeah, let's look at this one, and then we'll kind of get into looking at it. They do inequalities, kind of solving equations with some inequalities. We'll work that when we get to the homework itself and kind of look at that because it'll make a little bit more sense. The examples that they had in the book did not. Use the vertical line test to determine which of the graphs below is a function. Okay, it fails. You remember the shapes that I talked about? I said, okay, if it looks like this, this, or this, first off, it's touching it more than once, right? So now look at this one. All right, it didn't, because what you have to understand is that dash line right here is an asymptote, right? An asymptote is a line that the function approaches but never touches. So if this is going decreasing this way and never touches this line, and this one is decreasing as x approaches infinity, then they're never going to touch, okay? But when you look at this one, you can see that it's failing up here as well as down there because it touches it more. Those have shapes like that crossed over from one another. So that's kind of what you'll see in this particular section. We'll start working some of the examples and kind of bringing out some of the maximum, minimums, increasing, decreasing, vertical line test, and inequalities. Okay, so just that's a quick synopsis of section 1.3, and that's the end of part 1.